Hello guys, welcome back to the channel Mathemagix JEE. In this session, we are going to solve some good problems on coordinate geometry and calculus. We will focus mainly on differentiability and maxima and minima and applications of derivative in calculus and of course the linear differential equations. And then for coordinate geometry, we will mainly focus on straight line and circles and a bit of conic section. So let's start this session. The first problem here is saying that the perimeter of a triangle is 14 and two of its vertices are minus 3 comma 0 and 3 comma 0. Then the locus of the third vertex is what? Okay, so basically we are given a triangle like this. Let's say the triangle is A, B and C. So the perimeter of the triangle is 14 and two of its vertices are minus 3 comma 0 and 3 comma 0. Let us take B as minus 3 comma 0 and C as 3 comma 0. So the perimeter of the triangle is 14. That means the distance between B and C is 6 units. So AB plus BC should be 14 minus 6, that is 8. Now we are asked to find the locus of the third vertex. So in this case, the third vertex is the point A. So we have to find the locus of the point A. Now how can we find it? We have to recall an important property for conic sections. That is, let's say if f1 and f2 are two foci of the ellipse, then for any point P lying on the ellipse, we have Pf1 plus Pf2 equal to some constant, which is equal to the major axis, length of major axis of the ellipse. So 2a. So we can apply this property to solve this question, because here we are also saying that B and C are two fixed points and A is a point such that the sum of distances of A from the points B and C is constant and equal to 8. So we can see that it will be A, by the way. So AB plus AC will be 8. So we can say this point A lies on the ellipse whose foci are the points B and C. So we know the distance between the foci of an ellipse is 2AE. E is the eccentricity of the ellipse. So 2AE is equal to distance between B and C, which is 6. And we can also say that this 8 is equal to the length of major axis of the ellipse. So 2a is equal to 8. So from here we can get a is equal to 4 and e is equal to 3 over 4. From here we can calculate b square. So b square will be a square times 1 minus e square. So it will be 16 times 1 minus 9 over 16. So 7. So we can say the equation of the ellipse or the locus of the third vertex is x square divided by a square, which is 16, plus y square divided by b square, which is 7, is equal to 1. So option number A will be the correct option for this question. I hope you understood the question. The next question is on continuity and differentiability. It says we are given two functions f and g, where a and b are non-negative real numbers. We have to determine the composite function g of fx. If g of fx is continuous for all real x, we have to determine the values of a and b. Further, for these values of a and b, we are asked to tell whether this function g of f is differentiable at x equal to 0 or not. Okay, let us see. Now, if we simply calculate the g of fx, so here we can use the definitions of gx to find this function. So it will be f of x plus 1 when f of x is negative, and then it will be f of x minus 1 whole square plus b when this f of x is equal to 0 or positive. Okay, now we have to break this function in some intervals according to the definition of fx, because fx itself is a piecewise defined function, so we have to also break this function into some more steps. So here, if we use the definition of fx, this fx plus 1 is only valid when fx is negative. Now, if we look carefully in the definition of fx, here f of x will be negative only when x less than 0. So, we have to consider that case only. Here, if we consider this when x is less than 0, and we can say by the definition of this fx, x is less than minus a, then this fx plus 1 will become x plus a plus 1, because for x less than minus a, this fx becomes negative, and for fx negative, the definition of g of fx applies like this. Okay, then we have to consider this case. Now, how to consider this case? Here f of x is positive or equal to 0. Okay, so we can see in the definition of fx can be greater than equal to 0 for both cases. That means if we consider this case first, here fx will be positive if x less than 0 and x greater than equal to minus a. So x less than 0 and x greater than equal to minus a. Okay, then this definition of fx will be used. So here we substitute x plus a minus 1 whole square plus b. Now, if we consider this case, this definition will be used when x is positive or equal to 0. So x is greater than equal to 0, then we have mod of x minus 1 plus, minus 1 whole square plus b. Now, as there is a modulus here, we have to again break this function into intervals. Okay, let us do that on the next page. So here g of f will become x plus a plus 1, and then it will be valid when x is less than 0 and x is less than minus a. So overall x is less than minus a. Similarly, for this definition to hold, it will be x plus a minus 1 whole square plus b when x is less than 0 and x is greater than equal to minus a. So here it will be x belongs to the interval closed minus a to open 0. Okay. Now here we have to break this. We can see if x is greater than equal to 0 and less than 1, then this mod will open with the negative sign. Then it will become minus x whole square plus b. So simply we can write x square plus b when x lies between closed 0 to open 1. Then after x equal to 1, so x greater than equal to 1, it will be, the modulus will open with positive sign. So it will be x minus 2 whole square plus b. Now we have to simply check the continuity of this function, because in the question we are told that g of fx is continuous for all x. We have to check the limits of this function in the break points or the end points of the intervals. That means if we denote this g of fx by, let's say, a function h of x. Then limit x tending to minus a h of x will be simply 1, and then limit x tending to minus a, and this limit is 1 when we approach towards minus a from the left side of minus a. So here we say minus a minus, and here we say minus a plus. So limit x tending to minus a from the right side of hx is equal to, as x tends to minus a from the right side, we have to use this definition of hx. So here it will be 1 plus b. Similarly, if we calculate for x equal to 0, we get limit x tending to 0 minus h of x is simply, we are approaching from the left of 0, so this definition will work. That means a minus 1 whole square plus b, and then limit x tending to 0 positive h of x, which is this definition, so b. Now for hx or g of fx to be continuous, these two must be equal, and these two must be equal. So we get b plus 1 is 1. So b is 0. And similarly, a minus 1 whole square plus b equal to b. So a is equal to 1. That means a is 1 and b is 0. So we can finally find an expression for the g of fx. Let us go to the next page. Here g of f will become, if we put the values of a and b, a is 1 and b is 0, so it will become x plus 2. If x is less than minus a, so minus 1, then it will be x square plus b when x belongs to closed minus 1 to open 1, and then it will be x minus 2 whole square plus b. Now as b is 0, so we can omit that. So x minus 2 whole square when x belongs to 1 to infinity. Okay, this is the function g of fx. Now we can simply say that if we differentiate this function and check the continuity of the derivative of this function, we can tell whether this function is derivable at x equal to 0 or not. So we can differentiate piecewise. It will be 1 when x is less than minus 1, and then it will be 2x when x belongs to open minus 1 to open 1, because when we differentiate we remove the equality at the end points of the intervals. So it will become this, and then 2 times x minus 2 when this x belongs to open 1 to infinity. Now if we check the derivability of this function at x equal to 0, we can say that g of f x, this limit, so by the way this will be the derivative of this function. So this function derivative, if we calculate the limit of this function as x tends to 0 from the positive side and from the negative side, if they are equal, then we can say that the function is differentiable at x equal to 0. So we have to check whether this holds or not. Now we can see that no matter how we approach x equal to 0, from either side the limits comes out to be 0. That means the function g of fx is differentiable at x equal to 0. That's the answer for this question. I hope you understood this question. The next question belongs to the topic coordinate geometry, or especially the circles. It says for any real k, the circle this passes through two fixed points A and B. We have to find the locus of the point of intersection of the tangents to the circle at A and B. Okay. So first we have to interpret the given statement. What is this? This is a circle. So here this circle is like this, equal to 0. Now we can observe an important thing, that if we write this equation like this form, this is equal to x square plus y square minus 8 plus 2k times x plus y equal to 0. Now we can directly compare this form with a form which is s plus lambda l equal to 0. Now why did we choose this form? Because we know that if a circle is like this, whose equation is s equal to 0, and there is a line intersecting it at 2 points, the equation of that line is l equal to 0, then the circle passing through the intersection of this line and circle is like this, and the equation of this circle is s plus lambda times l equal to 0, where this lambda is a variable parameter. Now how to use this concept in this expression? We can see k is a parameter because k belongs to R. So we can say that 2k is some real parameter, which is, let's say, lambda, and it is the line l equal to 0, so x plus y equal to 0, and this is the circle x square plus y square equal to 8. So the circle that was given to us in the question is nothing but the circle passing through the intersection point of this circle x square plus y square equal to 8 and the line x plus y equal to 0. So like this. It passes through two fixed points A and B. Okay. So A and B are two fixed points which are nothing but the intersection points of this circle with this line. Then locus of the point of intersection of the tangents to the circle at A and B. Okay. So the circle that is passing through the intersection point of these two is like this, let's say. I am drawing a rough diagram here, like this. Then we have to find the locus of the point of intersection of the tangents to the circle. That means we have to use this circle. So the tangents at the point of intersection will be like this. So the point of intersection of the tangents is this point. Let's say this point is P. This is the point A, this is the point B, and this is the point P. Now we can assume this coordinates as alpha comma beta. So we have to find a relation between alpha and beta to find the locus of this point. Now if we look closely into the diagram, we can enlarge it by the way. This circle, which is s plus lambda l equal to 0, is this, and there are two tangents like this, and there is the line AB, which is given line x plus y equal to 0, and this is the point P, which is alpha comma beta. Now how to find the locus? We can use the concept of chord of contact here. We can say that the chord of contact of this circle of the tangents drawn from P to the circle s plus lambda l equal to 0 is nothing but AB. So we can directly write the equation of AB, which is t equal to 0. What is t equal to 0? So basically the equation of this circle is x square plus y square plus 2kx plus 2ky minus 8 equal to 0. So we replace this x square with x1 and y square with y1, then x as x plus x1 divided by 2, y with y plus y1 divided by 2, and leave the constants as it is. So we can see it will become, and what is x1 and y1? x1 and y1 are the coordinates of the point from where the tangents are drawn. So in this case, x1 is equal to alpha and y1 is equal to beta. So we can write this t equal to 0 as x alpha plus y beta, then 2k times, this will be x plus alpha divided by 2 plus 2k times y plus beta divided by 2 minus 8 equal to 0. So the chord of contact becomes x alpha plus y beta plus, this will be k times x plus alpha and k times y plus beta. So overall we can write this equation as x times alpha plus k plus y times beta plus k plus, this will be alpha k plus beta k minus 8 equal to 0. And if we compare this equation with the equation x plus y equal to 0, we can say that alpha plus k by 1 should be equal to beta plus k divided by 1. So from here we can get alpha is equal to beta. Now what does that mean? Alpha is equal to beta means that the P point should lie on a straight line whose equation is x equal to y. So the locus of the point of intersection of the tangents is nothing but x equal to y. So option C will be the correct option for this question. I hope you understood the concept behind this question. Let us proceed to the next question. Let fx be this function and it has its local maxima and local minima at a and b respectively. So a and b are nothing but the x values, and length of tangent drawn at a comma b to the curve, this is equal to what? Okay, so first we have to find the points of local minima and local maxima of this function. From here we can get f dash x is nothing but 6x square minus 6x minus 36. So it can be written like 6 times x square minus x minus 6. So 6 times x minus 3 times x plus 2. So we can easily evaluate the critical points of this function, which is x equal to minus 2 and x equal to 3. Now we can use wavy curve method to find whether these points are maxima or minima. These are the critical points and we apply the sign scheme plus minus plus. So here the function increases, then decreases, then again increases. We can see easily that x equal to minus 2 is a point of maxima and x equal to 3 is a point of minimum. Okay, that means local maxima is at x equal to a. So a equal to minus 2 and b equal to 3. Now we are asked to find the length of tangent drawn at this point a comma b. So minus 2 comma 3 to the curve this. Now this is a circle we know centered at 0 comma 3 with radius 2. Okay. Now if we observe carefully, this point itself lies on this curve. Now here one thing I want to point out, that always read the language carefully. If it were given that the length of tangent drawn from a comma b to the curve, this is what? Then the answer should be straightforward a 0. But if you answer 0 in this question, the answer will be completely wrong because the language is different. We are asked to find the length of tangent drawn at a comma b to the curve this. So as this point lies on this curve, we can draw a graph of this function here. So this is the circle centered at 0 comma 3 with radius 2 units. This is the point 0 comma 3. So this is the point minus 2 comma 3, which is a comma b. We have to find the length of the tangent drawn at this point. So the tangent drawn will be parallel to the y-axis. So the length of tangent will be simply, we can see the y coordinate of this point minus 2 comma 3. So 3. That means 3 is the correct option for this question. I hope you understood this question. Let us see the next question. It says this circle is rolled up by 4 units along a tangent to it at the point 2 comma 3. Okay, so we try to draw the diagram one by one. This is a given circle whose center is 3 comma 2. Okay, so here this is, let's say, our coordinate axis. This is 3 comma 2. So like this is rolled up by 4 units. The radius of this circle is, we can calculate, which is root under 9 plus 4 minus 11, so root under 2. Okay, and this is rolled up by 4 units along a tangent to it at the point 2 comma 3. So 2 comma 3 lies somewhere here. So the tangent to it will become simply this, and this circle is rolled up by 4 units. Now we simply roll up this circle. The circle, new circle, after rolling up this circle will become like this. This will be the new center. Now the question says, let this be circle C1. Okay, so this is nothing but the circle C1, and C2 is the mirror image of circle C1 about that tangent. So the mirror image of this circle about this tangent will be like this. So this is circle C2. C and D are the feet of perpendicular from A and B respectively up to x-axis. So A and B points are, I think, centers of the circles C1 and C2. Okay, so this is A and this is B. And A and B, if we drop the perpendicular from them to the x-axis, it will be like this. Then the area of the trapezium ABCD is asked. Okay, so we have to calculate this area. Now how to find this area? We have to simply find the distance between them. This is the difference of the x coordinates of the points A and B, and the sum of these parallel sides, which is the sum of the y coordinates of these points A and B. So we have to first calculate the coordinates of the point A and point B. Okay, now how do we proceed? We can use the concept of parametric equation of a line, because the distance traveled along the line is given in the question, which is 4 units. Now this is the center, which is 3 comma 2, and this is the point 2 comma 3. Now if we travel along the tangent, first thing we need to know is the slope of this tangent. Then only we can calculate the tan theta, and then we can also calculate sin theta and cos theta. So from here, if we differentiate this equation, x square plus y square minus 6x minus 4y plus 11 equal to 0, from here we get 2x plus 2y y dash minus 6 minus 4y dash is equal to 0. So y dash will become 6 minus 2x divided by 2y minus 4. So y dash at the point 2 comma 3 will become 2 over this will be 2. So 1. That means this theta, which is the inclination with the x-axis, this theta is 45 degree. Now from here we can easily determine the point of contact between C1 and C2, which is this, because the distance traveled along this tangent is 4 units. So from here we can say that this distance will also be 4 units. Now we want to calculate the coordinates of A. Let's say the coordinates of A is x and y. So x will be nothing but 3 plus this will be 4 times cos theta. So 4 by root 2, and y will be simply 4, sorry, 2 plus this will be again 4 sine theta. So 4 by root 2. So we get the coordinates of this point A will be 3 plus 2 root 2 and 2 plus 2 root 2. Now we have to find the coordinates of the point B as well. Now from here we can say that if we draw the diagram a little bigger in this page, this is the circle C1 and this is the tangent to them. This is the tangent to this circle and this is the mirror image of this circle. So circle C2, this is the point B and this is the point A. Now we calculated the coordinates of this point as 3 plus 2 root 2 and 2 plus 2 root 2. Now we know that when we roll up this circle by 4 units, the radius of this circle remains unchanged. That means this distance is nothing but root 2. So according to the property of mirror images, this distance will also be root 2. And we know that if we draw a perpendicular from B point as well as A point on the x-axis, this angle, this, let's say, let me highlight this angle by white. This angle will be same as the inclination of this angle. Now this angle we already know it is equal to 45 degree because this is nothing but the inclination of this tangent with x-axis. So this is 45 degree. That means this also should be 45 degree. Now from here we can easily find the y coordinate of this B point. How? We can simply complete the triangle here. So then we can use some trigonometry to find the y coordinate of this point B. As this total AB distance is 2 root 2 and this angle is 45, we can say that let's say this point is x. Then this BX distance will be nothing but 2 root 2 times cos of 45. So 2 units. And then this x C, sorry, this will be D point and this will be C point. So XD distance is nothing but the y coordinate of this A point. So 2 plus 2 root 2. So total distance BD we can calculate as 4 plus 2 root 2. And this AC is nothing but the y coordinate of this A point. So 2 plus 2 root 2. Now if we want to calculate the area of this trapezium, we can simply calculate by formula for area, which is half times distance between parallel sides, which is in this case 2 root 2 times sine 45. So 2, then sum of parallel sides, which is 6 plus 4 root 2. So the area comes out to be 6 plus 4 root 2 square units. That means option C will be the correct option for this question. I hope you understood this question. Now, this question is from JEE Main 2022, a PYQ. It is of the topic maxima and minima. So, a function is defined in terms of some modulus function and some greatest integer function in the interval this. And we have to find the sum of the maximum and minimum values of this function in this interval. Okay. So, first we have to break this function because there are modulus and greatest integer functions involved. First, we have to break this modulus. So f of x is, this mod will open with negative sign when x is less than 7 by 5. Now x is 7 by 5, that means x is 1.4, and we know 5 by 4 is nearly 1.2. So the point x equal to 7 by 5 lies in this given interval. So we can break this function in two parts first, which is, this is 7 minus 5x plus this greatest integer x square plus 2x when x belongs to 5 by 4 to 7 by 5. And then we can open this modulus with positive sign when x belongs to 7 by 5 to 2. Now again we have to break these functions because there are some greatest integer functions involved. Now how to break these functions? Because here are some function of x inside greatest integer. We have to simply consider this function first. Let us call this function gx, which is x square plus 2x. Now we simply check the behavior of this function gx. So if we differentiate this function, g dash will become 2x plus 2. So 2 times x plus 1, which is positive in this given interval. So we can say that this gx function is strictly increasing in this given interval 5 by 4 to 2. So if we calculate g of 5 by 4, let's say, then it will be equal to 25 divided by 16 plus 2 times 5 by 4. So this will be 10 over 4. This will be 65 over 16, which is nearly equal to 4 point something. And if we calculate the value of g of 2, then it will come out to be 2 square plus 2 times 2. So 4 plus 4 is 8. That means greatest integer of g function will be either 4, 5, 6, 7 or 8. So greatest integer g can take only these 5 values. Let us break them. Now we have to simply check whether in this first interval greatest integer gx actually changes or not. So if we calculate g of 7 by 5, it will be 49 over 25 plus 2 times 7 by 5. So 14 divided by, it will become 119 divided by 25. So 4 point something. That means for all x belongs to this interval closed 5 by 4 to 7 by 5, this function will become simply 7 minus 5x plus 4. So we can find the definition of fx like this, which is 7 minus 5x plus this will be 4 when x belongs to 5 by 4 to 7 by 5. Then after 7 by 5, let's say till x equal to alpha, the value of gx is less than equal to 5. And after x equal to alpha, the greatest integer of gx becomes 5. So gx is basically greater than or equal to 5. So when x belongs to closed 7 by 5 to, let's say, x equal to alpha, then we have this is equal to 5x minus 7 plus this greatest integer will be 4. So 5x minus 7 plus 4. And then similarly, we can say that for x belongs to alpha to, let's say, beta, this will be 5x minus 7 plus 5 and so on until x belongs to, let's say, some k to 2. And then the greatest integer will be 5x minus 7 plus this will be 7. And then for x equal to 2, the greatest integer will become 8. So 5x minus 7 plus 8. So like this. Now we can notice that after this point x equal to 7 by 5, the function actually increases. So the function increases in this direction. And before the point x equal to 7 by 5, the function actually decreases. That means the function must have some minima at x equal to 7 over 5. And what about the maxima? We can clearly say that as this function is increasing in this direction and as x is positive, the maximum value of fx will be obtained when x is equal to 2. So maxima at x equal to 2. So we can easily find f of 7 by 5, which is the minimum value of this function, which is equal to 4. And then we can also calculate f of 2, which is the maximum value of this function. Maximum value comes out to be 11. That means in this given interval, the sum of maximum and minimum values of f of x is simply 11 plus 4, which is 15. I hope you understood the concept that has to be applied while solving this type of questions. Now, the next question is from the topic linear differential equations. Let y equal to yx be the solution of the differential equation this 0 less than x less than pi by 2 with y of pi by 4 is equal to this and y of this is equal to this. Then the value of this 3 alpha square is what? Okay. So first we have to calculate the integrating factor of this differential equation. The integrating factor will be simply exponential of the integral of this function. So root 2 dx divided by 2 cos to the power 4x minus cos of 2x. Now how to evaluate this integral? Let us first apply the formula of cos 2x to simplify this expression. It will be exponential of integral root 2 dx divided by this we can write as 2 cos square x minus 1. So this will be 2 cos to the power 4x minus 2 cos to the power 2x plus 1. Now how to evaluate this type of integrals? We have to remember whenever we see only even powers of sine or cos, we usually divide by cos square x or cos to the power 4x or sine square x or sine to the power 4x. So in this case, we have to divide both numerator and denominator by sine to the power 4x. So exponential outside, and then integral root 2 dx. So this will be, if we divide it by sine to the power 4x, cosec to the power 4x, then dx divided by, this will be 2 cot to the power 4x minus, this will be 2 cot square x cosec square x, and then plus cosec to the power 4x. Now, how to evaluate this integral? We can simply write this as root 2 times cosec square x into cosec square x dx, divided by, this will be equal to 2 times cot to the power 4x minus this 2 times cot square x cosec square x, we can write it as 2 times cot square x, then 1 plus cot square x, and then this term we can write as 1 plus cot square x then whole square. So 1 plus cot square x whole square. Now from here we can easily observe, if we substitute t equal to cot x, then dt will become nothing but minus cosec square x dx. So here this will be exponential, then this integral will become root 2 times, this will be cosec square. So cosec square is 1 plus cot square, so 1 plus t square, and then minus dt divided by, this will be 2 t to the power 4 minus, this will be 2t square, and then this will be 1 plus t square, so 2t square minus 2t to the power 4 plus 1 plus t square whole square. Now we can see that these two will cancel each other, and this will become nothing but 1 plus t square whole square minus 2t square, so 1 plus t to the power 4. So the integral becomes exponential, then this root 2 dt divided by t to the power 4 plus 1 times 1 plus t square with the negative sign. So how to evaluate this integral? We have to simply divide by t square in both numerator and denominator. So this will become exponential, then integral negative root 2 times 1 plus 1 by t square divided by t square plus 1 by t square. Now this is a standard format for integration. Whenever we see this type of expression, we express this denominator in the form t minus 1 by t whole square plus 2. So we can write it is equal to exponential of integral minus root 2. Then if we substitute t minus 1 by t equal to p, then this will be dp divided by p square plus 2. So this will be simply exponential. If we evaluate this integral, then minus root 2 divided by root 2 times tan inverse p by root 2. So p we can again substitute back to t minus 1 by t, and t is cot x. So we can write this as e to the power minus tan inverse 1 by root 2 times cot x minus tan x, which is cos 2x divided by sine 2x with a 2. How can we write that? Because cot x minus tan x, if we express this cot and tan in form of sine and cos, we can get cos by sine minus sine by cos. If we take the LCM, we get cos square x minus sine square x divided by sine x cos x. If we multiply by 2 in both numerator and denominator, we will get this exact same form. So this will be nothing but e to the power minus tan inverse, then root 2 times cot of 2x. So this is our integrating factor. Now what will be the solution of this differential equation? The solution will be simply y times integrating factor, so which is e to the power minus tan inverse, this is root 2 cot 2x, is equal to integral of this function times integrating factor plus integration constant. So if we multiply this by this integrating factor, the exponential term will get cancelled. So we will be left with only x dx plus integration constant. So this will be x square by 2 plus c. So the solution of this differential equation will be simply y equal to x square by 2 plus c times e to the power tan inverse root 2 cot of 2x. Now to find the value of c, some information is given in the question. Y of pi by 4 is pi square divided by 32. So we get pi square divided by 32 is equal to, when x is pi by 4, so pi square divided by 32 plus c times e to the power minus tan inverse root 2 cot of pi by 2. So cot of pi by 2 is 0 and tan inverse 0 is 0. So this will be e to the power 0. So 1. That means c is equal to 0. So the function y comes out to be x square divided by 2 times exponential tan inverse root 2 cot of 2x. So from here we can easily calculate y of pi by 3. So y of pi by 3 is equal to, this will be pi square divided by 18 times exponential tan inverse. This will be cot of 2 pi by 3. So minus cot pi by 3, which is equal to minus 1 by root 3. Minus root 2 by root 3. Now in the question it says that this y of pi by 3 is equal to pi square divided by 18 times e to the power minus tan inverse alpha. So basically this tan inverse minus something we can write as minus tan inverse of that thing. So this root 2 by root 3 is alpha. So we are asked to find the value of 3 alpha square. So 3 alpha square is 3 times 2 by 3, which is equal to 2. So 2 is the correct answer for this question. I hope you understood the concept behind this question. This is the final question of this session. Let f and g be two differentiable even functions. Okay, we should note this statement that f and g are even on this interval such that f of 1 by 4 is 0, f of half is 0 and f of 1 is 1, and g of 3 by 4 is 0 and g of 1 is 2. Okay, that means x equal to 1 by 4 and x equal to 1 by 2 are the roots of this function f, and x equal to 3 by 4 is one of the roots of this function g. Then the minimum number of solutions of this equation in this interval is equal to what? If we carefully observe this expression, we can see that this can be written as derivative with respect to x of the function if x times g dash x is equal to 0. That means we can say if we somehow determine the minimum number of roots of this function fx times g dash x, then by Rolle's theorem we can say that the minimum number of real roots of the derivative of this function will be simply 1 less than the number of real roots of this function fx g dash x. So let's say this as phi x, which is equal to fx times g dash x. So if phi x has n real roots, then phi dash x should have at least n minus 1 real roots. Now how to find the minimum number of roots of this phi x? So then we have to use these informations. So f is even. Let us draw a rough graph of these functions f and g. F is even. So at x equal to 1 by 4, f is 0, and x equal to half, this f is also 0. As f is even, that means at x equal to minus 1 by 4 and at x equal to minus half, this function should also attain the 0 value, which means the number of real roots of this function is at least 4. So we can say that this function f has at least 4 roots. Similarly, if we try to plot a rough graph of this g function, g is also even. So here at x equal to 3 by 4, g is 0, which means at x equal to minus 3 by 4, g has to be 0 also. That means the minimum number of real roots of g is 2. This function g has minimum number of roots equal to 2. So by Rolle's theorem, we can say that the function g dash, which is the derivative of g, has at least one real roots. So we can definitely say that the product function phi x, which is equal to the product of f x and g dash x, has at least 5 real roots. So this function phi x has at least 5 real roots. And as phi x has 5 real roots, then by Rolle's theorem, we can again state that the derivative of this function has at least 4 real roots. So we can definitely say that this equation has at least 4 solutions in this interval, which is minus 2 to 2. So in this interval, the minimum number of solutions of this equation is equal to 4. So 4 is the correct answer for this question. I hope you understood this question. So till now we have solved 8 questions in total in this session. I will try to take more and more questions on other topics also like PNC, probability, and coordinate geometry, and then complex numbers, so that we can have a great amount of practice before your JEE main first attempt. Feel free to tell me the topics which I should cover in the upcoming session, and I will definitely try to take questions from that sections or topics.